Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us begin solving this step by step. Identify reaction 1 and product A. Benzaldehyde undergoes Perkin condensation with acetic anhydride, AC2O, and sodium acetate, ACO, with heat, followed by acidic hydrolysis, H3O+, delta. The Perkin reaction on benzaldehyde gives cinnamic acid, trans-PHCH is equal to JEE as product A. Molecular formula of cinnamic acid, C9H8O2. Degree of unsaturation, DU, is equal to 2 times 9 plus 2 to 8, 2 is equal to 18 plus 2 to 8, 2 is equal to 12 divided by 2 equals 6. DU of A is equal to 6, 4 from benzene ring including 3C is equal to C and 1 aromatic, actually, benzene ring is equal to 4 DU, C is equal to C alkene is equal to 1 DU, C is equal to O of ChO is equal to 1 DU, total is equal to 6. Moving on to the next step. Identify reaction 2 and product B. PHCH is equal to CHC is equal to O, CH3, benzalostone 4, phenyl 3, butane 2-1, reacts with Al, OCH 2, 3, aluminum isopropoxide, and isopropanol. This is the Meerwein-Ponndorf-Verley MPV reduction, which selectively reduces the carbonyl, ketone, to an alcohol without affecting the C is equal to C double bond. Starting material, PHCH is equal to CHC, is equal to O, CH3, molecular formula C10H10O. Product B, PHCH is equal to CHCH, or CH3, molecular formula C10H12O. DU of B is equal to 2 times 10 plus 2 to 12, 2 is equal to 20 plus 2 to 12, 2 is equal to 10 divided by 2 equals 5. DU of B is equal to 5, benzene ring is equal to 4 DU, C is equal to C alkene is equal to 1 DU, total is equal to 5. Moving on to the next step. Identify reaction 3 and product C. PHCH is equal to CHCH, or CH3 reacts with 1. Now I, iodoform reaction conditions, and 2. H+. Now I is sodium hyporiodite, used in the iodoform reaction. The substrate PHCH is equal to CHCH, or CH3 has a secondary alcohol with a methyl group adjacent, CH, or CH3 pattern is equal to methyl carbinol. The iodoform reaction converts CH3CH, or group, the alpha carbon gets tridenated and then cleaved. The iodoform reaction on PHCH is equal to CHCH, or CH3 would oxidize the CH, or CH3 to a ketone. PHCH is equal to CH-CO CH3 first, then the iodoform reaction cleaves it to give PHCH is equal to CH-CO cinnamate plus G3. After acidification, H+, product C is equal to PHCH is equal to CH-CO cinnamic acid. Molecular formula of C, cinnamic acid C9H8O2. DU of C is equal to 6, same as A. And for the final step, sum the degrees of unsaturation. DU A plus DU B plus DU C is equal to 6 plus 5 plus 6 equals 17. Therefore, the correct answer is 17. Therefore, the correct answer is 17.